What we have here is two parallel lines. Parallel lines run, well, parallel to each other, and they never cross, in theory, right? At least if you keep it in two dimensions. These two lines will never cross, so we call them parallel lines. One way to remember parallel versus perpendicular is these L's actually make parallel lines. So that's one way to distinguish. We compare parallel lines with perpendicular lines. Alright, so there's another set of axes. Okay, perpendicular lines cross at a 90-degree intersection, right? So, right, think of an intersection of streets that just come right onto each other in a perfect kind of T. That's what we refer to as perpendicular. Okay. What we're interested in now is the slopes. Okay, so this is M1, let's call this M2. The slopes of these two lines are the same for parallel lines. Parallel lines have the same slope, always. Right, the rise over run is the same for both these lines. So I'm just going to say same slope, M1 equals M2. All right. Perpendicular lines, their slopes are as different as you can possibly get, right? This one's going a different way. It connects at 90 degrees, completely different slopes. So we say that the slopes of perpendicular lines, let's call this one M1, slope 1, and slope 2 here. We'd say that they are negative reciprocal slopes. Negative reciprocal. Slopes. Okay, and what that means is you take one line and it's the negative reciprocal of the other line. So you could think of one way of writing the reciprocal as just 1 over, but really if this slope is in a fraction, you would just use the reciprocal where you switch the numerators and denominators. We'll see that in an example. But there's the two takeaways. Parallel lines have the same slope, perpendicular lines have a negative reciprocal slope. Let's try this in an example. Find the slope of a line that is parallel and perpendicular to a line passing through 6, -2 and 1, 4. We can do that. Let's try A here. Remember, parallel lines have the same slope. Okay, so we just have to find the slope of this line, and then we can go from there. Recall that the slope is rise over run, y2 minus y1 over x2 minus x1. All right, so let's call this one x1, y1, this one x2, y2. So 4 minus a -2. So I subtracted -2 from 4 over 1 minus 6. Okay, so that gives us 6 over -5, so -6/5. Okay, so there's the slope of this line. Now we want the slope of any line parallel to it. It doesn't tell us which line, it just says any line, a line, it's arbitrary. A line parallel to a line with a slope of -6/5. Well, parallel lines have the same slope, so -6/5 is going to be our answer there to part A. All right, part B, perpendicular lines have negative reciprocal slopes. Negative reciprocal. It's much easier to do the math on this than to write the words negative reciprocal. Okay, so we already know what the slope is. Remember, negative reciprocal means M2 is -1 over M1. So what that means is we change the sign from negative to positive. If this was positive, we change it to negative. Some people call this the opposite reciprocal for that very reason. And we find the reciprocal. So I'm changing the sign to positive, and I'm going to write, instead of 6/5, I'm writing 5/6. That's the reciprocal. And it's the negative reciprocal, so it becomes positive. There we go, 5/6.